everyone everyone obsesses over finding that perfect magic prompt for their AI, right? But if you look at the latest engineering blogs and academic surveys on platforms like LangGraph or UiPath, you'll realize relying on a single prompt is, well, it's practically outdated.
Yeah, exactly. It's really all about the underlying structure now.
Right, it's about optimizing the compute graph of agentic systems. So today we are doing a deep dive into exactly when you should use static versus dynamic workflows, to balance cost, latency, and reliability. Okay, let's unpack this.
Well, to get this optimization right, you really have to start with the baseline, which is static workflows. These are, they're entirely deterministic. A human developer lays out a very strict predefined path well before the AI even sees a task.
I always picture this as like a factory assembly line.
That is a great way to look at it, yeah.
Right, because if you're processing incoming invoices, step 1 always extracts the data, step 2 validates it, and then step 3 hits the ERP system. It's super rigid, but what's fascinating here is how that rigidity actually becomes your biggest advantage for cost and latency.
Absolutely. Because the path is fixed, the language model is only called exactly when it's needed. You bypass all those continuous, expensive decision-making loops.
Oh, that makes sense.
Yeah, and plus you get transparent compliance. You always know exactly what the system did and why it did it. But of course, the second an ambiguous task hits that factory line, things go wrong.
Like, say, a customer emails a complaint that just happens to look like an invoice.
Right, exactly. The whole thing breaks down, which is why the industry pushed toward dynamic agent, systems that can actually reason on the fly.
Right.
They can look at a highly unstructured task, independently select which tools to use, and just loop until a goal is met.
But wait, here is where it gets really interesting to me. If static paths are so cheap and reliable, why not just build a massive complex static tree for every possible edge case? I mean, why risk using a dynamic agent if it gets confused, loops endlessly, and just burns through my API budget in an hour?
Well, you've just described the exact fear keeping engineers up at night. They actually call it agent anarchy.
Agent anarchy, wow.
Yeah. Letting an agent freely plan its own path drastically increases token costs and latency because, well, it constantly hits the LLM to decide its next move.
Right, it has to think about every single step.
Exactly, and building a static tree for every single edge case is just impossible to maintain. But you are right to be wary of the dynamic alternative. I mean, for enterprise applications, pure unbound autonomy is simply too risky.
Because they need certainty.
Yeah, even a 1% hallucination rate in business-critical processes is completely unacceptable.
Okay, so we're stuck then. Static is cheap but dumb, and dynamic is smart but might bankrupt you. So what does this all mean? How are developers actually bridging that gap without compromising either side?
This is where engineers are optimizing the graph itself. So one of our academic sources highlights a concept called LLM as scheduler, or LAS.
Okay, how does that work?
It essentially puts a tiny, really cheap model right at the front door, and its only job is triage.
Oh, so it acts like a dispatcher.
Exactly like a dispatcher. If it recognizes a standard invoice, it just sends it down the cheap static factory line. It only wakes up the heavy, expensive dynamic agent if it sees something complex it doesn't recognize.
Wait, really? And the data shows this reduces token usage by over 60%, right? And it drops latency by 40%. That is huge.
It is huge. And if we connect this to the bigger picture, this is exactly why platforms like LangGraph or PO Agent were built to create these hybrid agentic workflows. They confine the unpredictable, stochastic behavior of an LLM strictly inside individual nodes while keeping the overarching routing between those nodes entirely deterministic.
So you're essentially putting a highly creative agent inside a reinforced box right on the assembly line.
That is spot on. You get the reasoning where you need it, but because the belt moving between the boxes is deterministic, it won't break your system.
Right.
And because that overarching path is hard-coded, you can actually perform time travel debugging.
Time travel debugging, meaning what exactly?
Meaning you can rewind an error step by step to see exactly where the agent went off the rails. It's like checking the security cameras in your factory.
Oh, wow, that is incredibly useful.
Yeah, you can replay past execution states perfectly, and you can easily insert human-in-the-loop checkpoints where the system halts and just waits for a person's approval before moving forward.
Right, so knowing when a task requires a highly creative agent versus a reliable factory line is going to save you immense amounts of compute and money.
Excellent.
So the holy grail isn't making one giant model smarter. It's building better roads between specialized models.
Yeah, that structural shift is everything right now, though this raises an important question.
Oh, what's that?
Well, as LLM compute costs inevitably drop closer and closer to zero over the next few years, will we eventually just let dynamic agents run absolutely everything? Or will the fundamental human desire for deterministic, auditable control keep those static assembly lines alive forever?
That is a great question. I guess we'll have to see if the factory ever fully shuts down, just something to mull over before you build your next AI workflow.